So there's nothing left in the kitchen anymore?
Nah.
Ah, okay. Yeah, that was quick.
I know what the CNC really There's that one? Oh, what? Wow, that's not comfortable.
All right, great. I'd say it's about 4 o'clock on a Thursday afternoon. That means it's, as always, time for some more practical system skills. So, what did we do on Tuesday? Well, we talked a little about like some basic networking stuff. Spent then most of the lecture talking about SSH, how you can authenticate there, that there is like this cool thing called public key cryptography, and why you definitely should use it in the form of like the SSH protocol, and that there are like a lot of like cool things that you can do with it. And the coolest is basically you can install your key there, and after you create kind of your private public key pair, and then just basically if you set up your SSH properly, you can just like SSH and then directly like into the remote machine, or you can like run stuff there, you can download stuff there, and so on. So basically SSH is the tool to go if you want to work remotely. I was also talking briefly about like secure copy and rsync, though not really in detail. And so, I mean, the commands are pretty similar to copy. However, as always, there's a little more on it. And so the first thing I want to kind of talk about is about archives. And so the basic motivation for that is that it's pretty inconvenient if you kind of want to send an email with like files around, or you want to transfer files, if it's many tiny small files. And the reason is also like why this is so inconvenient is that actually many like larger software packages have trouble handling a lot of small files. Hence, you always want to kind of create one large file, compress it ideally, and then transfer it. And the tool on Unix machines to do that is called tar, which is short for tape archiver. And so where this comes from is basically, as usual, like many of the terms in the Unix world, it's all about like kind of the big mainframe computers which were used in the 60s, 50s, and 70s. And so the idea of this tool is basically to kind of put everything into one big file that would get then dumped into like some magnetic tape device. And the resulting file is for that reason called a tarball or tar archive. And the extension that it usually has is like .tar. And so it sounds like this is all pretty historic. However, actually, tape archiving is still kind of the tool to use in like the big data center. So if you ever get the chance to walk into like a big data center, I highly recommend to check it out. And I mean, it's a little hard to see, but I mean, slides are also online. You basically have like still these super big storages which have like a lot of magnetic tapes, and usually the data gets also put into like large files using the tar command, for example, and then just like stored there for like backup reasons. So what can you do with tar? Well, you can basically create one file out of many, and you can even kind of conserve the directory structure. And as usual, there are a bunch of options which are kind of convenient. And so tar is a little special in that sense that you can actually drop the hyphen if you want to use those options. So you basically can just like combine them as usual, like putting them together into one string, but you don't have to write the hyphen. And you also see that across the internet, if you whatever look up tar commands or so on, that many people just drop it. And this is, however, just specific to this command. So in general, that doesn't work. So what do we have here? Well, we have one option to extract files, that's like the X. Then we have V for verbose, that's like basically to print whatever is in the archive when you put it in or extract it. Then we have F, which specifies the file name for the archive to either create or extract from. We have C to create an archive, And we have one more special option, which is like C, which is if you specify that the archive will get like gzip, so it will get compressed. So how does it work? Well, we have here a couple examples. So first we can basically just create one file. First comes like kind of the name of the archive, which is like also easy to mix up. And I mean, it's actually quite rare to get this right on the first try. And you can basically just like specify after that file paths of whatever files or directories that you want to include. You extract the files by, again, just putting a couple options. So here I put in like the V, which is verbose, which just shows you that, but you could actually drop it if you wanted to. You could also extract the files to one target directory, which you can do with the -C switch. And what you can also do is you can just extract one file out of an archive. And to do that, you basically just have to give it the path within the archive. And there's like two more, which are pretty cool. That's like you can list the contents of it, or you can actually add files to an archive after you've created it. So let's see how this works in practice. All right. Again, we have here a lovely terminal. So we still know, like from last lecture, we can just use no SSH in its fullest flavor. So we just have to type where we want to log in. We just want to be tux today, not cline. So awesome, we're already like in tux's machine. And so what we can do now is like whatever create in your directory. Let's call it here. Let's go in there. Let's create a couple of files, like something like tux loves seafood. And we write it to some file, just using standard out redirection. We can just touch another file. We can create a directory, put another file in there. And so now we can just create like an archive pretty quickly by using like create. Then we do it verbose file, and we just call it like archive.tar. And now we want to basically add like all the txt files and the folder. And so if we do this now, basically all of this gets now added into like the archive. So we can now list it.
What does CVF stand for again?
So C is for create, V is for verbose, and F is for file.
What's the verbose again?
The verbose basically shows you here which files are added to the archive. And that's like all the paths basically. So then we can kind of list the contents using TF. We can also add a new file. So let's say we create a new file, like say something like cline loves seafood too, especially penguins. All right, and now we can add this by using like rf. So we specify the archive, and then cline. We can also put like in a v for verbose. So we see this is added. And now if I list the archive, I have now here cline added basically to it. Okay, two questions, or three questions actually. Okay, first.
Can you run ls?
ls, yes, of course.
Okay, so it doesn't like move them into the archive file, or just...
So it doesn't delete them. I think that's the question, right? So you basically, yeah. So they're still there. So you basically just serialize them all into this tarball archive. So it's a non-destructive operation. So you have to manually delete them after if you wanted to. Okay, another question here.
What's the T and F?
The T and F, so the T is basically the option to just list the file. I have to say I don't know what the T is standing for, but it should be in the man page, and the F is just to specify basically the archive file, which is the archive.tar.
Okay. Wait, so you don't need like an append? You don't need an append for the archive that's hard?
Well, that's what the T option does.
What append? It's just append whatever you had?
Sorry, that's what the
So you have
R option does,
R
right?
is it? Okay.
Sorry, R is it, yeah. So T is to list and R is to append. Okay, another question here.
Yeah, what's the benefit of using like a tar, like an archive, versus just another folder?
So the idea is basically, so if I now go here and I list my folder, right? I basically have maybe a lot of tiny files and a complicated structure, and I want to transfer all of this to my local PC, or Mac or machine or whatever you want to call it. And so by just putting it all into one tarball, I have one file that I can easily transfer, compress, or like send around. And so typically if you work on a server and you want to transfer a lot of files, a good way to do it is you first put it into a tarball, then you compress it, and then you SCP it over to your machine, and then you unpack it.
Okay, can you like not compress a normal full?
Yes, I mean, tar itself doesn't compress anything at all. So it just puts everything together. So for example, if we do like something like a hex dump of like archive.tar, right? It looks like this. It's like one giant file, right? And we see, that's kind of the cool thing of like the hex dump, right? You see already still like kind of some structure in it. You see like file.txt in this is in this big file, and the contents of it, right? Then you have like here somewhere tux loves seafood, right? So the tux file gets added here and so on. Same goes like for file 2.txt, right? Here we see like some of the content of the file which we added and so forth. And we basically have now like everything compressed into one 10K file, which is cool.
Tar automatically compresses it?
No, tar doesn't compress it. But like we just serialized all the data in there into one tarball.
So his question was, can you just compress a folder with all of the documents?
Like, could you, if you wanted to transfer a bunch of like small files, could you just move them all into one folder and then just move that? Like, what's the benefit?
Yes, but you still have to then copy each file over, right?
Oh, and tar provides a way to do that.
Yeah, it's just one file that you copy essentially.
Okay.
So you have it at one location saved.
Yeah.
And I mean, the other thing is like, it's also like kind of good for storage reasons because you store it at one place in your file system. All right, so there's a couple more things that one can do with like tar, and that is like you can compress tar files. And for that, usually on Unix, there are like multiple compression programs available. There are many more out there in the world, and you can basically install many more like 7-zip, RAR, zip, Snappy, and so on. However, there's kind of 3 standard tools which are usually shipped on a Unix platform. And that's like gzip and gunzip, bzip2 and bunzip2, and xc and unxc. And so they all use like kind of slightly different compression algorithms, always kind of trading off the speed versus like the compression ratio and how good they work. And basically, it's always your choice what to use, depends on your use case, right? Sometimes if you have maybe like multiple gigabytes, maybe you want to compress it faster or you want to compress it better. So it's always kind of your choice which tool to use here. And so the cool thing about that is you can, as I said, use them to basically compress any file, and it's especially useful like for tarballs. So how it works is usually you first create the tarball and then you run it through this program, and you append the extension of the compression program to like your tarball. So then you get like kind of with these extensions .tar.gz, right? .tar.bc2, .tar.xc.
You call them tar balls?
Yes.
Like VALL?
Yeah.
That refers to a tar file?
Yes, that refers to the tar file.
Is that vernacular or is that like the proper term?
That's the proper term for that, yeah.
Why is it called a ball?
I don't know, that's like historic reasons. Like, for some reason, someone decided to call it like that. Alright, so how does it work? Well, there's like 2 options, right? Either we can create first the tarball and then run the compression over to create the file, or we can do something very cool, which we already had, and that's we can use pipes. So what we can do here is basically we just like create a tar file on the fly, put it out to standard out, and then use our compression to create the file, which again would write it to standard out. So we use input or output redirection in this case, right? And put it into like an archive file. And the same way also works the other way around. And so here's like a couple new things. Because as always, it depends how the program is written, so we always have to learn a little syntax. But so how it works for like kind of tar and these is like you basically specify just a dash which tells tar to write to standard out instead of an archive file name. And if you want to kind of unzip it, which here I just did like with a bzip2 it works for the others too. You also just have to specify like -c. There you basically tell the zipping algorithm to not like kind of create the files out of it, but rather pipe it through like standard in of the next command, and then you can basically have again the same thingy going on with tar. And here basically the dash is that it should read like from standard in. So let's check how this works. So we're here, right? So kind of the easy thing to do is like you would just like use archive.tar, and I think then it's the second parameter. Oh, that's the other way around. Or it's just like one. Let's see quickly the man page. Okay, so it should be gzip archive.tar.gc, and then you give it like archive.tar.
So you put the destination before the source?
Yeah, I have to check actually in the man page quickly. Because I usually use like the other one or create it directly. Okay, anyways, let's just use directly the pipes. Though there's also a way to do it directly on the fly, but I mean it's kind of inconvenient. So, so what you can do is basically we have our tar file, like as in here. So we basically have tar cf minus, and then we take like all the files basically, and then we pipe it through. So this would work basically tar cf, then the dash for like kind of to put it to standard out, and then we have just like here only like the txt files, and then we take like gzip, and then we can redirect it to like compressed.tar.gc, and so this would basically create like our file, and as we see it should be smaller. Okay, let's remove archive. Okay, yeah, so it's way smaller than before. And then we can also like kind of unzip it using like kind of the same syntax by again using piping. However, there's like also another option, and that is like we can use the C to kind of do those two steps in like one. And here the trick is basically there's like multiple options again. The most common one is just to use like C or Z, and that will basically just use gzip per default to kind of create the archive, the compressed archive. And if you want to specify a different algorithm, you can either use like piping syntax, or you can use like J for like bzip2. There's also a general compress tool usually installed like on a Unix system, which is called compress, which you can select with like a large C or A to kind of auto-determine the compression program based on the extension. So that's kind of pretty convenient, and I would say it's the recommended way to create quickly archives. So let's remove that. And so what we can do is basically we have here again like all these files. So here we just want to do like now kind of an XC compression. So we do CVAF. Then we call it like all.tar.xc, and then we just select everything. So this puts everything into one compressed archive. And so we have it basically now here, and I mean it's way smaller than the rest. And so again, we can use like all the tools, right? We can use T to list the contents. So we have like all tar, and then we see like what's been compressed in there, right? Or we can now also like kind of, let's say we want to remove everything except the .xc file. So how can we do this? We can run something like remove.txt, right? And then we can remove the folder quickly. And then we can do like tar, and now we have to extract it, so we use an X, then F, A, we want to be verbose, so a V again. Then we do all tar xc, and so if we run this, then we get like all the files back in the directory. And so that's kind of a convenient tool, and yeah, it's something definitely to play around with to get comfortable, but it's just like the standard way to kind of quickly work with like files and directories. Yes?
What's the normal standard output of tar?
Like without any options, or?
Without, is it like the compressed file or the tar file?
So,
Because you pipe that directly to the compression command.
yes. So if you don't specify kind of, if you don't do like the piping thing and you don't specify the dash, right, it would just like do the natural thing, which is like if you do like X, it would just take all the files out and create the directory structure in your current working directory. And on the other side, like, I mean, if you kind of do it differently, right, if you take like, for example, a tarball and you want to, if you take like the files and you want to put it right, it would just put it in. And if you don't specify V, it wouldn't print anything, so it would just kind of uncompress or compress, or like serialize or unserialize. I mean, it all depends on the options you give it. But like, I mean, why is this kind of also like a tool that's like kind of really important to learn is like when you look for software to install on your machine, you typically find them in like different archive formats, and they're usually all tar based. So usually have like the selection depending on what compression tool you want to use, right? And then you can like download software like binaries and resources and so on, usually as a compressed tarball, like .tar.gz online. Okay, great. All right, this brings us to today's topic, which are processes. So what's a process? Well, a process, simply spoken, is nothing else than an instance of a program which resides in memory. And so each process has now a lot of properties. Amongst there are like 4 important ones, and that is like each process gets a unique process ID assigned, and that's like for a running process. Then it has a parent process ID, which is the process ID of the process who launched the process. And then we have like 2 more interesting fields. One is UID, which is the user ID, so that's the user to which the process belongs to, and the difference is it's like kind of a user it belongs to. It's not necessarily the one who started it. So there's also a difference between like kind of what's the effective user ID and what's like the one who launched it, right? But user ID in the broader sense is usually the one who started or who it belongs to, right? Like, I mean, if you type a command, then it's you who runs it basically, unless you configured it somehow weirdly with like groups, permissions, and so on. And then there is a third one, which is TTY, and that is short for teletype writer. So again, comes all historically, thinking of like kind of a mainframe, and usually when you wanted to have like output and input, you had a teletype writer attached to it. And today, this is basically referring to the terminal to which the process belongs to. So that's like the terminal it's attached to kind of, when you type stuff, receives it as standard in, and where it puts stuff out as standard out or standard error. So, as always, there are a lot of tools on Unix to work with processes. And the first one, which is very important, is the process status command, or short PS. And so what PS does, it basically prints the running processes. And if you just use it by default, it basically prints out like 4 columns. Here, like with a process ID, the terminal it's ascribed to, the time, which is like the CPU time this process used, and then the command. So,
2 terminals? Don't you only have 1 terminal open at a time? So why would you have 2 terminals?
well, that's pretty easy, because let's see how this works. So, let's say I'm here on my Mac. So if I run, okay, I have to exit Tux machine. So if I run now PS, I see there's only 1 terminal, which is like my iTerm, which I use, right? However, I could also just open another terminal. And so now if I run like PS here again, I have another terminal open, which here in this case is my sys terminal, so this is referring to this one here. But I also love iTerm, so let's open another shell here. And so now if I run it, I have 2 iTerm terminals open. Because iTerm is kind of nothing else than a wrapper around the actual system terminal. You see basically now I have 3 terminals, like bash terminals open, which is basically 1 for my first iTerm, 1 for the second iTerm, and 1 for like just the sys terminal which I opened. And I have 2 times kind of the terminal processes, which are like kind of the 2 iTerms. And now we see I have here 5, 6, and 7, so I have 3 underlying terminals, or like teletype writers, on my system right now. I mean, of course, if I kind of kill these, then I have like this. All right, let's jump again back into Tux machine.
So if you were to just open another terminal within the same one without opening a different window, would it also open another terminal? Like if you were to just do bash to open a bash?
Well, it depends how it's like implemented, right? I mean, if you would run like another bash, then yes, it would open another terminal. Okay. Ah, there we go. Yeah. All right. And so, as always, we can kind of configure our command to display information we want to know. And so how it works for like the process status command is we give it like an option, which is -o, and then we give it a bunch of keywords which are separated by a comma. And so they can be used to like process to display a lot of interesting information about our currently running processes. I just put here like a couple of keywords. As always, they're way more, and like you always refer to the man pages for that. But like the thing that's like pretty cool to see is like kind of we can use it to display the user, the group, the user ID, process ID, parent process ID, then the tilde writer, time. We can also display things like the percentage of CPU it uses, and then also the command with like all options. And where this is like kind of useful is like later next week when we talk about like string processing, you can use that to kind of find specific processes that are running, which you might want to identify by like, for example, their arguments and so on. So yeah, let's try this out also quickly on the terminal. All right, and so if I would do that, what I could basically do is say ps -o, so I want to have user, group, user ID, process ID, parent ID, and a terminal. And so I would get here like the output. However, I missed the command, so it's at the command. And here I see basically on my Tux machine right now as user Tux, I have only like 2 processes running. I have like my kind of bash shell running, and I have like kind of the PS process running, which I just executed to display that stuff. Question here. Sorry, what?
The -o option.
The -o option basically allows you to select which information to display via the process status command. And here it's basically, I said like, well, I want a user column, a group column, user ID, process ID, and so on.
What's the TTL?
The double T is referring to the terminal. So that's like kind of the Taylor typewriter. And so here it's just one, which is like PTS/0, and PTS stands for pseudo terminal slave, and that's because like when I communicate via like SSH, I also need like some sort of terminal where to write to, and that's kind of the one that like SSH opens up for me. All right, speaking of that, now we have like some more interesting processes, and there's like kind of 2 terms that are used in the Unix world, and one is like a daemon, and so a daemon is a process that runs continuously and is not attached to a terminal. So when we kind of compare that to what I just like listed via like PS, we saw that basically both of them had a terminal, and also like on my Mac, basically every of the listed processes had a terminal. However, there are also like processes who are not attached to a terminal, and those are like usually the ones that run like independently to provide some sort of service. And kind of the example we sort of already know about is like when you SSH into the machine, you need some sort of server program to accept the connection, right? Check the keys, authenticate you, and so on. And that's like SSHD. And the kind of naming convention is that typically daemons are having like a D at the end. So if you see like some process with like a name where the D is at the end, the chance is pretty high it's actually a daemon process. And then there's another interesting type of process, and that's a zombie process. And so a zombie process is kind of a very odd process because it's a process that's not actively running, but kind of still has an entry in the process table. And that means basically it still has like a process ID assigned to it. And the kind of idea of that is like, depending how you manage processes, you might end up sometimes with zombie processes, and kind of the good way to deal with them is to remove them from the process table.
Do you ever do that unless you're coding in C?
Can you maybe repeat the question, please?
So they talked about this in CS33, which is coding in C. We had to remove zombies, but like that seemed like very system-oriented type of thing that you'd actually have to do. Like I would imagine that just interacting with the terminal, you're going to have to remove zombies.
Yes. So here's the deal about that. So the thing is like when you execute code, right? And if it's like compiled code, you usually have no idea what's going on. And there are programs which might behave very oddly or very badly, and that depends. Like, for example, you have like some issues, like whatever, there's a crash in the program, or it's a complicated program which actually consists of multiple processes, which are all interconnected, communicating with each other. And for some reason, you maybe just killed a part of it, or a part of it terminated, and there's still some process existing, but they were sent to like be stopped or to sleep, or they never get scheduled any CPU time. And what you end up with is like then basically a zombie process. And so from a system, a user perspective, what you want to do is you want to know how to deal with those, and you basically want to get rid of them because they might clutter your system and slow you down. And that's also actually like malware might kind of just like spawn a lot of zombie processes to kind of slow down your machine. Like that's kind of just like an administration thing to do. All right, we have a couple more options for process status. Amongst us -a and -A. And so what they do is basically they list all processes that are running. Because I mean, if I said like, well, I only have like 2 processes running, you know, like bash and like the PS process, right? I mean, you wouldn't quite believe me because like there has to be like a lot more running on a system to provide like SSH access, whatever security, and so on. And so -a is basically the switch to reveal all of this. And it's actually quite a few of like processes. So when I go back to the terminal and we just like hit like ps -a, okay, here we don't see it because we're not an admin, but I think on my Mac it works. So if I do here ps -a, I see there is a lot of applications running. And so if I had like kind of the rights to reveal everything, if I was like a root user, I would see like also all the sys processes, like for example the SSHD and so on, which are running on the machine. And so for that reason, what's kind of convenient is if you want to go through them, you can pipe them to like a pager. Like for example, you can just put like hat if you just want to get like the first ones of them, or like tail, right? Or you could use like something more interactive, like say less or so, where you kind of can then scroll through them. All right, let's see like one more example. So here I use like A to get like more processes out than just like -a. I can again just combine it with other options like with -o. So when I do that, like let's say on Tux machine, and I do like -a, I see now here a lot of like sys processes running, right? And I can also like kind of add again group user, process ID, parent process ID, user ID, the terminal and the command. And then I see like there's a lot of stuff actually running on my system. And again, here we see like, for example, here there is one process running with like a D at the end, so this is likely to be like a daemon process.
Terminal ID is 0 question mark?
Yes, we're coming to that in 2 slides. So, and that is like, yeah, we have one more flavor, which is like the -x option. And what this does is now it kind of restricts all the processes to the ones that you own. So before, when we kind of go here, we see pretty much all the processes, right? We see a lot of like processes run by root. But if I do like ps -ax, it's just the ones that I would own. So if I do like user command process ID, user ID, and so on, those should be only the ones that I'm affected. Well, Sorry, I have to get rid of the A flag because it shows all. There we go. So this is like now only the ones that Tux is running. And we see here, yeah, we have like this weird process, which I'm gonna talk about soonish. And then we have like here our SSH daemon, which kind of handles the connection to my MacBook. All right, the next thing I want to kind of talk about is like how a process is actually born in Unix. And so how this works is basically that there are like two versions or two steps to create a new process. And that's like you can either fork a process or you can execute a process via like exec. And so what are those doing? Well, so if you fork a process, what basically happens is the currently running process, the active process, is taken. It makes a copy of itself. So everything that's in memory gets copied. And then it basically runs again, and like some flag is raised. And you basically have then like two copies of this process, which might change behavior internally then. And for this reason, what basically happens is that like this fork process inherits pretty much everything from the parent process, but there are like two differences. Like one is like it gets a new process ID, and the second is like you basically have not kind of the thing that if you have some I/O device involved or so, that the processes kind of compete for the same I/O device, so I/O doesn't get cloned, but the rest gets kind of cloned. And the other option how you can kind of create a process, you can use execute, and that's like nothing else doing then. It replaces the currently running process with a new process. Meaning basically you have some process running already, it's living in some process space in memory. Then if you run the exec command in it to load like a new program, this program will override the currently running process space and replace it basically. Basically fork is like to kind of make a new one, and exec is just to replace it. So let's see how this works. All right, when we kind of run PS again, and now again with like the A flag and the X flag to list like pretty much everything, there are some interesting processes there. And that is like we have one which is called systemd, and this process is interesting because first of all it has not a terminal, so it's a daemon process, not attached to any terminal, and then it has a process ID of 1 and a parent process ID of 0. And typically it's run by like the root user, which you also see because the root user typically gets like the user ID 0. And so what this is basically when you start up your computer up, one first process needs to be kicked off, and that's in this case systemd. And that's like an init process, which itself then triggers via fork calls all the other processes to start up on your system. And so if you want to do like some kind of serious Linux, Unix hacking, what you can do is you can basically specify in some configuration file for systemd what services, processes to launch after like initial setup. And this could be like your GUI process, which provides a graphical user interface, services like SSHD to log in remotely, or other things like web server and whatever. So it's basically creativity is unlimited in this case. And yeah, in Mac OS X it's called a little differently. Still the same principle there, it's just like called launchd. And so this is basically the root process which creates all other processes. And so in order to kind of settle more how this works, there's also another cool utility, and that's called PS3. And so PS3 can be kind of used to show which process created which other process. So we can kind of also take a look into that. So we can just run here PS3, and then we see that basically systemd is the first one, right? And it creates a bunch of like other processes. And I think somewhere there should be also like bash, yeah. So we have here kind of the tree of like our SSH connection, right? And then has like a terminal itself, and then PS3, which was like executed. All right, I kind of want to go a little more about like how kind of this forking executing works. So there's like some nice graphic here. So basically we have our initial shell process, which is like bash, right? Then we can fork a new process, like for example, if we execute like a subshell or so. Then in this child process, typically exec is run. So this would like replace the current process with whatever we want. And then the parent process waits till like the child process completed, and then it basically continues. And this is also actually what's happening when you issue a command in bash, right? So what bash does is basically it forks itself, then it runs the exec command on the child process to replace it with the program whatever you want to run. The parent process, like bash, waits for you, and then after your program is determined, it kind of continues so you can issue the next command. So this is basically what it works. And practically, we can also do a cool example for this. So let's check out how this works. So I'm still here in my shell, right? So if I run now a normal command, like listing clines directory, let's see what we still got here. I basically issue it, bash gets forked, replaces itself with a list command, then the child process terminates, and then we go back to the parent process. And because it's pretty fast, you don't see like any lag here, right? However, I could do something else. That is, I could use, instead of kind of the forking, which has bash inherently built in, I could use the exec command. So now if I do exec list home cline, what will happen? Well, the current process will get replaced, so I get this output. So what happened? Well, of course I get the output, right? I see what's in clines directory, but my connection dropped. And the reason is because I basically replaced my bash SSH session with the list command, which executed, still wrote the output, and then it didn't return to the parent process, therefore the connection dropped. So that's kind of the other way of how you can launch a command. Yeah?
What if you do exec on this now, like just on this? You just with the window is closed.
Okay. So here, okay, that's interesting actually. I think you have to kind of run this special case on the actual system and terminal to see like something, because iterm is like some wrapper around it. But if I do now here exec, usually this happens, and that is like you have a process completed, right? Because the bash process got replaced. But like in the iterm it didn't work because probably some bug or so, or they didn't code for the special case. All right. Okay, seems still to work. Great. All right. Okay, great. As always, we can also work with like all these cool things, like the process ID, the parent process ID, user ID, and so on. And that is, of course, in bash, we have some cool variables. And that is to have like kind of the process ID, we just use like the double dollar. So we basically look up the value of $. And then we can use the same for like parent process ID and the user ID. And basically, if I would run such a script, right, we see here tux executes that, right? We have here the process ID of the bash interpreter, which is running, right? And then I run the script, which is just over there. Then we see it gets forked off, right? So another process ID. However, the parent process ID is like here kind of the same because I use like kind of bash here to invoke the program. And we also see like here user ID. And under GNU Linux, there's also another program which you can use to kind of look up process IDs, and that's like process ID off, and then you just specify the name of the command, and it basically does like a search for that. Okay, speaking of that, I would say, considering it's already Thursday, and we are all looking forward to the weekend, let's make a short 3-minute break, and then we will resume at like 48 or so.
so it's vars, but the file is var.sh.
Oh yeah, that's just a typo.
Typo, okay.
Sorry about that.
Okay.
Alright, great. Let's continue. Alright, and that's like the next big topic for today. And that is like, how can we actually work with processes? So far we just discussed how it kind of works under the hood a little. But what we really want to do is like, we want to know how we can launch and work with like long-running processes. And so for this, there are basically like two types of like process, or two types how we can kind of classify them. And that's like, we have a foreground process, which is kind of a currently running process, and that's the one we can interact with like via the terminal. And we can have a bunch of background processes which are like just running in the background but don't require us to kind of issue input or like confirm their actions in some way. And in order to interact now with process in general, Unix has a system which is based on signals, and so what we can do is we can basically send signals to processes. And the command to do this is called kill, and to see like what signals we can send, we can just simply run kill -l. So if we look on our tux machine, what we can do, we can basically run kill -l, and we see there's a bunch of interesting signals that we can send to a process. And how it works is basically we have like here again our synopsis taken from the man page. We can basically issue just the signal name, then the process ID where you want to send it, or like multiple ones, right? Always remembering kind of the syntax, right? If there's like ... it means you can repeat the previous argument as often as you like. And then we can basically use this to kind of interact with process in any way we deem fit. And the default signal, if we don't specify a signal name or a number with which the signal can be also identified, is it will issue a sigterm signal, which is a terminate signal for the process, which kind of works well with the default name of kill, because it will ultimately kill the process if we don't specify another signal. And so there are a bunch of signals. I already listed, there are many more, but like the ones we typically care about when we kind of want to manage processes are the following ones. The first one is the hop signal, short for hang-up signal, and that is always sent to a process when its controlling terminal is closed. And why this is kind of important is when you work remotely and you close your shell, for example, by using the exit command or just clicking the X on your graphical user interface, you will send this signal to the process. The second one is the interrupt signal, or short int. And what this does is basically it's a signal to tell the process, please stop doing what you're currently doing. And for what this is used typically is like if you have a REPL, like for example Bash or Python or any other program, which could be also like for example a database command line interface, then you usually issue an interrupt command to tell it, please stop the currently executing command and wait for my next input. Then we have another one, which is like the quit signal. And this is like already getting a little more serious. This is like basically if you have some misbehaving process in your system running and you want to end this process but still want to gracefully end it but kind of see what's going on, you would send this signal and it would produce a core dump. So basically a dump like what the whole system status is to see and debug what's going on. Then we have one that's like the kill signal. So that's like with code minus 9 or 9. And this is the kind of the ultimate way to determine or terminate a process. In that regard, that here the program is just basically loaded off memory. Nothing is told to it, so it can't like kind of take any action to gracefully exit, shut down, delete resources, just basically kill it and remove it from the process table. And one that's kind of a bit below the quit signal is the terminate signal, which is like kind of the default one when you just use kill without specifying the signal code. And that is you basically ask the software politely to terminate, and that's the normal way to stop a process. So basically what you would do is you would first usually try interrupt, right? If this doesn't work, you would go to terminate. If this fails, you would go to quit, and your ultimate way to terminate a process is just killing it using like a kill command or signal. And so the cool thing is when we now work with a foreground process in Bash, what we can do is we can issue certain signals using some key combinations. For example, we can have our interrupt signal issued typically using Ctrl+C. We can issue a quit signal using Ctrl and the backslash. And then there is one more special sort of signal, though it's not a signal in the process sense, and that's Ctrl+D, and that basically sends an end of file marker. For example, if we have like some command that's waiting for input or so, this would kind of send the end of file, so it would usually terminate, depending how it's written, what it is processing. And so the order to go is basically first try out Ctrl+D, then Ctrl+C, and if this doesn't work, then Ctrl+backslash, and that's how you basically terminate a process in your terminal. So we can also kind of try this out. We have in our lecture 7 folder, or let's do it like this. We have here a long-running script. So if I would execute this, what would happen? It iterates, but now I want to get rid of it. So I just issue Ctrl+C, and this will send the interrupt signal and would interrupt execution of this script. Could do also something else. I could start it, and I could go a little harsher on it, and I could just like put like here the quit. Oh, it didn't work, but core dumped a core. So it seems Bash is not listening to me, but I could use again like the other signal to use it. And depending kind of what signal you use, it always depends how the program is itself written and what it kind of catches as a signal. And so you basically have to try out these different signals if you want to terminate a process. Other option is, so let's start another kind of tux login. We could also just use the kill command to issue all of this. So if we go in here, and let's maybe edit the script so it runs a little longer than it already does. So here what I did is basically I have a for loop, right? echo something out, and I use the sleep command to just artificially make it run pretty long, and changing this here to 100 to make it run even longer, so like 100 seconds or so. So what I could do is like I could start it, then I can find out with like ps minus x what's running. I see here I have my long running script, and so now I just want to kill it. So I would give it basically here the process ID, and so if I kill it, it gets killed immediately. Of course, I can use the other signals as well. I can basically go and issue, like, I think 2 was like the interrupt signal. So I could use this here. Sorry, I first have to find out, of course, which process ID this has, because it changed, right? Because I restarted it. So I could do something like this. Okay, let me just quickly check which signal number it was. Okay, this didn't get it. Interesting. But okay, let's just kill it with like a -9. So that's like kind of our ultimate weapon. So here we just have it like killed. And as I said, it always depends how the program is kind of written to see like what type of like signals it accepts. But the tools are basically, you could either kind of use like, you know, Control-C to issue like the interrupt signal, or you could basically just use the kill command and give it like kind of the signal. All right, yeah, here's again just like pretty much all what I said, like kind of the steps to take to terminate a process. So you try to like interrupt, you can set then the end of file marker. If this doesn't work, you can just kill it. Again, if this doesn't work, you kind of can do the core dump thingy. And the ultimate ratio is always like to issue like a kill -9 signal to like the process, which will just like terminate it ultimately. All right, the next thing you want to know is like how we can actually launch a background process. And so how this works is basically you just specify your command, but at the end you append an ampersand, and this will launch a background process which will detach from the terminal in some way, in the way that like it kind of doesn't wait anymore for your input. However, it will still print the output to the terminal. So let's see how this works. So what I could do is basically, I'm here, and again, I want to now launch my long-running script. Just maybe getting rid of this window here. And now I want to launch it as a background process. So I do this like with like the ampersand. And so what it does is like it basically enqueues that to my job queue, here identified by like a number, and like here the process ID. And as we see, now magically kind of output happens, and I could actually type within it. And that's because the background process is still kind of subscribed to like my standard of the terminal, but I could still do stuff, right? Like, for example, it prints this output, and I could like run something like hello world, right? This is like completely messy now, and now it prints like hello world and so on. So, well, what can we do now? All right, so we know it's still running. So kind of the solution to get rid of it is again to just kill it. So let's SSH in as like tux again. And now we kind of list it, right? We see it now has like this process ID here. So let's just get rid of it and kill it. And then we are back to our normal terminal. However, what can we do to kind of get rid of this weird output when we start a background process? Any ideas? What would we do if we want to get rid of like this weird output here in our terminal? What should we do with a background process? Any ideas?
Direct it or type it as well.
Exactly. You would basically use output redirection, right? So you could basically redirect everything to like some file, let's say log.txt. And I mean, this one doesn't print to standard error, but you kind of want to be sure to also send the standard error to like standard out. And so if you do this, now you have like kind of your background process running, but it doesn't mess around anymore with your terminal. And so if you kind of want to see where it is, you can basically print out the log, right? We see it's still computing. So if I now cat the file again, it has a couple more iterations done, right? I could also do stuff like I could basically kind of use tail or something like that, and this would basically just like kind of let me know that like this process is still running, right? And so the next question therefore is, first of all, what jobs or processes are running right now? And for this, again, in Unix we always have a command. So let's start another one. Here I have another script which also like kind of runs forever, but this time doesn't produce any output. So if I start it right, nothing happens. But like if I kind of send it to the background, it gets appended to the list of background processes. So if I run the jobs command, I see here now that I have kind of these two processes running, which is like one, the long-running script, right, with like all the redirections, and I have my other script, silent slow script. And so what I now want to do is like, I mean, of course I could kill it by looking like at the process ID and so on, but maybe I want to resume this process in my terminal. And for that, there are like kind of two tools, and that's like FG and BG for foreground and background, and they can be used to bring back into my terminal one of these in the background running processes. So how it works is like here, I basically have like the numbers, right? I have like my long running script, and so I could do something like foreground and then 1. Oh, okay, the job has terminated already. Let's take 2, right? And so now I'm kind of back in my slow running script, and I'm again subscribed to that. And that works like also with other programs, and you can basically set them also to the background if you wanted to. So let's see how this works. Again, I just killed it with like the Ctrl+C. Let me clear the screen to have some more space. And that is, I have another kind of keyboard shortcut, which is Ctrl+C, and this allows me to suspend my foreground process to become kind of a background process. However, it's not quite what it does. So what it actually does, it just suspends it, meaning it just stops it and puts it on a temporary hold. If I want to run as a background process, I have to kind of issue a background again. So let's see how this works. Let's say I want to start my Python interpreter. Now I want to send it to the background. Here I see now I stop Python and it's running now as a background process. But in order to like kind of keep it running, I either have to kind of send it as a background process, so I can do this using this. So now it's running as a background process. You see that the ampersand got like appended, so now it's a background process. Or if I want to bring it back into my foreground again, I just run foreground 1. That needs another enter. And now I'm back into my Python interpreter, so I can do something like print some stuff or so on, right? And I could also like end this process, and Python luckily understands Ctrl-D, which sends an end of file marker, and that would jump out of my Python process. So that's kind of the way how you could send processes back and forth. All right, the next interesting idea what we could do is, let's say we have some beefed up machine somewhere where we have SSH access, and we want to launch some long-running script. So what we could do is we could basically just start like the whole thing using SSH, right? Redirect everything and then just let it run. And if we put like the ampersand, it wouldn't like wait till it terminates, but rather it would just like put it as a background process, and then we can continue working. And so I also kind of want to demonstrate that quickly. And so for this, I actually added like something cool here. And that is like I have some complicated process, long-running script, which produces plots of the Mandelbrot set and like a zoom in, so it just spits out a lot of images. So if I run this, right, again I do here like a Ctrl-C, so I send interrupt, so the whole thing stops. I see it produces a couple of PNG files. So naturally what I could do, right, I would create a tar file out of those. So I would cv-set-f, right, and then I would just like create the file like, let's say, images.tar, and all the PNG files, so would get created, right? Then I would basically go into my local machine, maybe go to my downloads folder, right? And then what I could do is I could just SCP the whole thing over. So here I would do tux at CS6 demo, right? It's all stored in tux's home directory, so I would /home/tux, and then just get like the tar.gc file. Just put it here. Okay, it's complaining. Where are we? Oh, it's just a tar file. I just named it tar. Alright, so it gets over like here. Let's just quickly rename it to tar.gc. Can do this. And now we want to like kind of untar it. So we just run this command. Also have to put a C. Right, and so if I now run open dot, which is kind of one cool command I can run on a Mac, I see I have here a bunch of like images, which just like has like kind of a soup for the Mandelbrot, and I think you already saw like in the lab how you could stitch that together using FFmpeg to a video or like a time lapse or something like that. And so the cool thing is, well, maybe I don't want to block my machine working, but I rather want to like kind of have everything run remotely and issue me a couple of things. So what I could do is like basically I could do like SSH, then I do again tux at CS6 demo. Now I have to issue the command, and because the command has like some white space, I basically put it into quotes. So here I would just run it, right? So it's stored under hum tux, and then let's list here again the directory. I see it's called run_mb.sh, so I could do like run_mb.sh. So if I started this now, oh, okay, it's complaining. Why is it complaining? Okay, it's complaining because of the path. This can be quickly fixed, so I would just go into quickly the Python file to fix it. So this is stored in bin, so let's go and so I just have to append this, and then quickly fix the zoom file. So here we have like kind of this. So as usual in Vim we just delete it, then we add it here. Oh, again, I have also to add like kind of the GeoModel program. I get all of this, right? Alright, so let's start it now. Okay, thank you Python, always a pleasure. Okay, anyways, so why is this complaining again? It doesn't match any other indentation level. Oh yeah. Alright, cool. Now it works. So these are like the problems when a programming language is designed with white space having a semantic meaning. However, some people unfortunately do that. Right, so here we see now our process is running, right? And basically it would block me from working, right? So I don't want to do this, so just killed it again. And so what I could do is I could just like run this now as a background process, right? So I issue that, but it's still subscribed, right? Bad. Okay, what could I do now? So first of all, I still have like everything subscribed, so I want to kind of redirect this to like a file log, so home/tux log.txt, right? Then I want to do like kind of send the standard error out. So if I run this now, I have no more issues, right? Because I detached basically from my own terminal, and I just ran as a background process over there. And so if we look now into this, okay, we hope some frames should appear. Okay, but there aren't any. Something went wrong. What went wrong? Well, as I said, we basically closed here the terminal which issued that. So in order to fix this, we have to disable the hang-up signal. And for that, there is another command which is like called no-hub. And so if when we issue this now, basically it issued it. And now we go to ps-x. and we should still see like the whole thing running, and it wouldn't receive a hang-up signal to kind of get killed. But again, this always depends on like kind of what. Okay, this always depends like how the actual program is implemented. And so then if we now check, yeah, we get now the frames right. So the program that we started remotely as a background process didn't receive the hub signal because we kind of suppressed that, and now we have it producing frames. And again, what we could do is like we are now in downloads, right? And we could just SCP everything. So we have like SCP tux at CS6 demo. Then we have home tux, and now it's like all stored home directory, right? So we could also use like a wildcard to transfer files. And then we see how it works. Well, okay, here is SCP starting. And so I hope with that demo, it's kind of clear why tar files are actually quite useful, because you basically want to compress them and just like have one file transferred, which ideally also, when you use rsync, you can resume your download. And if it's one file, it's way faster, because else rsync has to check the whole directory tree, and it's like way slower. Great. All right. So here's again like kind of the whole problem with the SIG-hub signal, and that's like kind of one of these things to know when you start a remote process, that you should basically just always append like or prepend no hub before it, so it doesn't terminate. And then after that, you basically can now use any remote machine out there in the world to do some background work if you want. That's also what one usually does, right? You kick off some job somewhere, let it run as a background process, and then a couple days or hours later, you check back and like just fetch the output, which you first tar and then send over via SCP to your local machine if you want to evaluate it. Awesome. This is like the end of our lecture today. So next week, we're going to talk about text processing, all about CSV, TSV files, xargs, how to use pipes, pages with text, how to kind of do the whole processing across lines, words, and so on. A little about regular expressions and how to use cool editors like set, which is a streaming editor, or awk for like writing some simple string manipulation programs. Great. So long, and thanks for your attention.